Integration services scripting is the easiest way to extend the functionality of integration services, although scripting is actually something of a misnomer. Traditionally, the term script applied to weakly typed, interpreted languages like VB Script and JavaScript. This is not the case with scripting in integration services. When you extend integration services with script, you use the full Microsoft Visual Basic and C# programming languages with all of their capabilities, including strong typing, compilation, and access to the power of the .NET framework. In the context of integration services, the term scripting simply refers to .NET code that resides in the package file. This means that you cannot reuse the code in other packages, but it also means that it's relatively simple to add and update the code inside the package. If you have code that you want to use in many packages, you can write a managed assembly, store it in the .NET Global Assembly cache, and add a reference to the assembly in your integration services project. You can also create your own classes, write support methods, and so on. You truly have the full power of a Visual Studio project at your disposal. You can add scripts to an integration services package in two main ways. One is to use the script task to add script to a package's control flow, and the script component in order to add script to a package's data flow. The two components are quite different. The script task usually executes once in the package, or perhaps once per loop in a looping container. The script component executes once per row in the data flow, and may end up executing millions of times each time the package executes if there's that much data to process. This is why there are separate components for the control and data flows. The requirements of each are quite different. As a result, the code you'll write for each is quite different as well. I'll be exploring both the script task and the script component in this course in some detail, and you'll learn about how they are both similar and different. A second option to extend the functionality of integration services is through custom component development. This involves building a custom .NET assembly that uses the base classes and interfaces of the integration services runtime library, the same classes Microsoft used to build other integration services components. This is quite a bit more complicated than using script, but it also has benefits that script doesn't provide. The major benefit of component development for integration services is that you can reuse your components across multiple packages. You can add your component to the toolbox in SQL Server Data Tools and then use it as you would any of the built-in tasks or transformations. Another benefit of custom integration services components is that you can share them. There's a small but growing community around integration services custom component development, and you can find component assemblies and source code for download or purchase so that you don't need to do everything yourself. Custom component development for integration services is definitely an advanced topic, and I'm not going to cover it in this course in any depth. But Microsoft has a number of samples that are available that you can explore and learn from. All right, let's get back to scripting now. If you're going to extend the capabilities of integration services with your own code, it's highly likely that you'll start with integration services scripting. But where should you begin? So, first question is, what can integration services scripting do? So, a quick list involves things like you can extend control flow with the script task. So the script task allows developers to build their own custom control flow logic, essentially building their own tasks to implement features that are not available in the built-in tasks. You can also extend a data flow with the script component. The script component lets you build data flow sources, data flow destinations, and data flow transformations, all from a single toolbox component. It's really pretty amazing. You need to configure it, and you need to write different kinds of code for each of those uses, but a single component does it all, and does it rather elegantly. This enables your code to access data stores that integration services doesn't natively support, and enables transformations that the built-in components don't provide. You can also access the full power of the .NET framework. Because integration services scripting uses the full C# and Visual Basic .NET languages, your integration services script can access any class that is built into the .NET framework or implemented as a .NET assembly, which means that your code within the package can essentially do anything. There really are no practical limits. So that's just a small sampling of what you can do with scripting. But the possibilities are significant. You essentially have the same full-featured development environment and resources as any standalone Visual Studio project, all embedded within your package. The majority of integration services package development involves implementing a control flow and one or more data flows, and this is where integration services scripting excels. The next logical question is when to use integration services scripting. Although there's no hard and fast answer for all situations, there are a few basic guidelines you can use for deciding when to use integration services scripting. First and foremost is when the built-in functionality doesn't do what you need. Believe it or not, this really doesn't happen as often as you might expect. Earlier versions of integration services, earlier versions or the older version of data transformation services, yeah, it happened all the time. Less so with the modern implementations of integration services. The combination of built-in tasks and transformations and integration services support for variables and expressions provide a lot of functionality right out of the box. Still, you'll probably encounter one or two situations on any integration services project where the built-in functionality falls short. Frankly, it's pretty rare these days where I'm building a non-trivial package where I don't use scripting in some small way at the very least, and sometimes in very complex ways. All right, second situation is when you need unique functionality for only one or small handful of packages. You can't reuse integration services scripting code in other packages unless you copy and paste the code. Okay, there are other ways to reuse code, but using the scripting component, that's the only way you can do it. So if you need to access the same logic in more than a few packages, it probably does not make sense to use scripting. Consider instead building a custom component or a reusable assembly instead. But if this is something specific to just this one package, you need to process this particular kind of data in a particular kind of way, then scripting is probably the answer that you need. But moral of that story, though, is that always look for existing functionality in other components, tasks and components that may already exist. There's a pretty good chance that if it's a common sort of scenario, Microsoft may have already implemented it in one of the other built-in components or tasks. Another thing to consider is when you need to add simple functionality to a template package. So this is kind of an exception to the previous guideline. And it's a situation in which you have a small script that you need to include in every package in your SQL Server Data Tools project, but which will be easy to maintain. In this situation, you can add the script to a template package and then create new packages by copying that template. This is a basic feature of Visual Studio on which SQL Server Data Tools is built. And then finally, you'll want to consider when you're prototyping functionality for a custom component. If you know that you're going to need a custom integration services component but aren't ready to invest the development effort right away, you can build your logic in script and then migrate it to a component once you know that everything is working right. You'll have a few little things to convert and change and adapt, but the overall logic, you can validate that the overall logic is going to work for that custom set of code. All right, then those questions kind of beg this last question of when should I not use integration services scripting? And this is a question that too few integration services developers ask, and that's when to avoid integration services scripting. Scripting is a very powerful tool, but it's not the right tool for every job. And so there's a few things where you want to consider, some few scenarios where we want to consider not using scripting, where it just may not be the right choice. First is when you can get the same functionality by using existing tasks or transformations, and I've already kind of mentioned this. Don't underestimate the capabilities of the components that ship with integration services. The control flow task and data flow components provide the solution to 99% of the problems that you're likely to face when building packages. Before you start writing script code, make sure that you can't simply use the components that Microsoft already wrote for you. Most components are highly configurable, so they may do exactly what you need. And you might be able to customize a component just by a judicious use of an expression, for example. Another time you should consider not using scripting is when the unique functionality you need will be used in many packages. So this is a flip side of something I talked about earlier. If you're going to need the same custom logic in more than one or a small handful of packages, and especially if the logic is complex, then it's likely that an integration services custom component or assembly is the better solution. The effort involved in maintaining the same script code across a large number of packages can be overwhelming. And trust me on this, you can very easily lose track of all the instances of that custom bit of code that you find a bug in and you need to go in and fix the bug in all these different packages. It can be tough to find that code. Okay, and this is a little bit of an older issue, but if you're new to integration services and if you've used SQL Server Data Transformation Services or DTS, then with a DTS mindset, you're probably thinking you need to use scripting more often, but that's not the case with integration services. Now, DTS hasn't been around for quite a while, so this is less of an issue now. But again, if you've used older versions of DTS, this can be an issue. Because SQL Server 2005 introduced integration services. Before that, DTS was the extract, transformation, and load, or ETL tool, of choice for many projects. But the built-in capabilities of DTS were inadequate for any but the most trivial tasks. Because of this, developers often used ActiveX scripting in DTS to implement the bulk of the functionality in many projects. You had to write a lot more code in DTS. And ActiveX scripting, which uses VB script as its language, is severely limited compared to the scripting components in integration services that, again, have the full access to Visual Basic, C# and the .NET framework to do anything that you want. And I just want to emphasize, it's very important to understand that scripting in integration services is not the same as scripting in DTS. Although integration services used to include an ActiveX script task, it existed only for backward compatibility and interoperability with upgraded DTS packages. So Microsoft really supported DTS going forward into integration services for quite a long time, a number of years. And so yes, you could write VB script code just like the good old days of DTS, which really weren't all that good. But there's really no reason to do so. That task, the ActiveX script task, was deprecated in SQL Server 2008. If you're using 2012 or 2014, it's not even an issue anymore. So I'm really just addressing this to people who use DTS. Okay, let's talk about the integration services object model. To take full advantage of the power of integration services scripting, you need to understand the integration services object model. The integration services object is a huge set of .NET namespaces, classes, enumerations, and interfaces that provide access to the integration services runtime. It consists of hundreds of components and provides virtually all of the functionality provided by integration services. Now, a full discussion of the integration services object model is way beyond the scope of this course. But for most of your scripting work, you'll use only a small handful of namespaces and classes. And so now I'm going to describe a few of the more important namespaces and classes, the ones that you're likely to use when writing scripts for integration services on an everyday basis. Okay, so first up is namespaces and the Microsoft.SQLServer.DTS. This is the root namespace and the location of most of the integration services functionality. The namespace doesn't have any useful features itself, so you'll never need to add it as a reference directly, but it's the root of everything else you're going to use. And notice that you'll see a recurring pattern here that Microsoft never updated a lot of its APIs to get rid of the old DTS name. So these are all SSIS, or integration services, but they very frequently use DTS as part of the older name. Next is the Microsoft SQL Server DTS.task.script task. This contains the core functionality of the script task for adding script to your package's control flow. Then there's the Microsoft.SQLServer.DTS pipeline. This contains the core functionality of the script component for adding script to your package's data flow. So these last two are the ones that you're mostly going to be interacting with, for first one being the script task in a control flow, and the second one being for data flow for a script component. And then there's the Microsoft.SQLServer.DTS runtime. And that contains functionality to create packages, custom tasks, and other package control flow elements. Usually you're not going to use these classes directly in your own code, but you'll see support code, which integration services manage, that uses this namespaces classes. Okay, so those are the main namespaces that you'll encounter. And then there's a few classes. And the first one is Microsoft.SQLServer.DTS.tasks.scripttask.scriptObjectModel. This provides a programmatic access to objects defined within the package. So when you create a script task, you have access to the class through the global DTS object, which is an instance of the script object model class that is automatically available in each script task. So this is how you get access to other objects within the package. Next up is the Microsoft.SQLServer.DTS.tasks.scripttask.scripttask. And I just love some of the redundant names in the hierarchy. And this provides access to capabilities that are not available in the built-in integration services task, including properties that you can get or set on the script task itself. And the next class is Microsoft.SQLServer.DTS.pipeline.scriptComponent. Serves as the base class for data flow script component development. And then the last class that you commonly use is the Microsoft.SQLServer.DTS.pipeline.pipeline_buffer. And this provides access to the memory buffer that holds the rows and columns that the script component processes in the data flow. That's one thing about the script component in a data flow. Very frequently you're going to have to deal with buffering rows of data, because often you need to process a set of rows or all rows in the data flow as a set, such as for certain aggregations. So the pipeline buffer gives you access to some of those features that you need in order to access the data rows. Okay, and just one more time to note about the use of the old DTS name. Basically, the product group decided that it was more important to provide backward compatibility with code written by early adopters of integration services than it was to have consistent naming in the object model. And so now that a lot of people have written code with the old names using DTS, Microsoft has carried the names forward to later versions of SQL Server. So it's just one of the ugly downsides of backward compatibility. In this case, I think be happy for it. That's not always the case when Microsoft implements backward compatibility. But in this case, I think it's a good thing. And just be aware that DTS, just translate in your brain that it's SSIS, and you'll be fine.